Okay, so now we need to apply all that. We need to calculate stresses at any point. So to calculate stresses, we need one point. A point in a body can be represented by a cube like this with six faces, so that we can draw all the stresses in all directions. So for this stress element, we have sigma, normal stress for each surface, in x direction. This is sigma in x direction, and we have sigma in y direction, and we have sigma in z direction. So these are normal stresses. This is sigma z, x, and y. We also have shear stress, and you know shear stress is tangent to the surface. So for the upper surface, you see we have shear stress of y. This is y surface. So shear stress of y in x direction and in z direction. Tau xy and tau yz. Same with all surfaces. This is in 3 dimensions. If I simplify that and only look at 2 dimensions, x and y, I will have sigma in x direction, okay, that is equal from both sides, and sigma in y direction. That's normal stresses for x surface, for y surface. And I will also have shear stress, shear for x direction. So you see shear stress in x direction is trying to rotate the element counterclockwise in this case. Shear is equal, right hand side and left hand side. And we will also have shear stress in y direction, in y surface, x direction. So in y surface, shear stress in this case is trying to rotate the element clockwise. So for equilibrium, shear stress in y direction must always equal shear stress in x surface. So shear stress in y surface equals shear stress in y surface, but opposite direction. Okay. Okay, that's what the plane stresses. So stresses in Cartesian directions, sigma x, sigma y, and shear. Okay, so let me go back here. Now, now we have stresses in main direction, in Cartesian directions. Stresses in x direction, stresses in y direction. So let me give you an example here. Let's say you did all the calculations, and according to your calculations, sigma in x direction was 150 megapascal, and sigma in y direction was 200 megapascal. These were your results. Now, you need to make a decision. You need to choose a material. Let's say you have a material with strength of 210 megapascal. Is it safe to say, since strength is larger than stress, the element will be safe? You never know, because what you did is calculation in this line and this line, so in this direction and in this direction. But the stress element, or any point, will be stressed in all directions. So there will be stress with different value in this direction, stress with different value in this direction, stress with different value in this direction, and you don't know which direction is the maximum stresses.